questions 11 through 20 on the 2015 grade 12 AMC 12B. The line 12x plus 5y is equal to 60 forms a triangle with coordinate axes. What is the sum of the lengths of the altitudes of this triangle? Let's draw the coordinate axes and let's see what we can get. Well, the line obviously will be something like this, and from that equation you can very quickly figure out the x and y intercepts. When x is 0, y is 12, so this is 12 right here, and when y is 0, x is 5, so that's 5 right there. So since this is a right angle, one altitude is 5 and another altitude is 12. So the sum of the altitudes are 12 plus 5, but then we've got one more altitude, and that altitude is of course going to be represented by a line like this that's perpendicular to that side. And how do we figure out the length of that? Well, first of all, I'll just call it A for altitude. We can use areas. So, for example, the area of that triangle is 1/2 base times height, which would be 5 times 12. This is 5, and that's 12. But the area can also be represented as 1/2 base times height, using that as the base and that as the height. So it would be 1/2 base, which we haven't actually calculated yet. This is easily calculated by Pythagoras. It's just going to be 13, right? 12 squared plus 5 squared will be that hypotenuse squared. And when you do that math, you'll get h equal to 13. So it'll be 1/2 base, which is 13, times height, which I have called a. And from this, you get a is equal to 60 over 13. So that's the third altitude. So that 60 over 13 goes here. And that's it. Now we just have to add these up. And when you add them up, let's see, here we got 17 plus 60 over 13. And then when you get a common denominator, you get 221 plus 60 over 13. And that is 281 over 13. So number 11, the answer is E. Let A, B, and C be three distinct one-digit numbers. What is the maximum value of the sum of the roots of the equation x minus a times x minus b plus x minus b times x minus c is 0? Well, I don't encourage you to multiply this all out. The fact that it's factored already is very helpful. We can factor once more by taking out the x minus b and then x minus a plus x minus c, like that. So that means I got x minus b, and this becomes 2x minus a minus c. So that means x is equal to b, or 2x is equal to a plus c. That means x is equal to a plus c over 2. So these are the roots right here and right here. Now the sum of the roots, therefore, will be b plus a plus c over 2. And we want to maximize. Okay, well, a, b, and c are three distinct one-digit numbers. So if I want to maximize, I'm going to choose the largest one-digit numbers, and those are 9, 8, and 7. Now the only thing I don't know is the order. So we experiment. Let's try, well, exactly like that, 9, 8, and 7. And let's see what we get. It'd be 9 plus 7.5, and that is 16.5. And when you switch things around, like for example, if you use 8 for B and then 9 and 7 for the other two, or 7 for B and 8 and 9 for the other two, you'll get a sum that's less than 16.5, and you can try that out. So number 12, the maximum is 16.5, which is D for number 12. Quadrilateral ABCD is inscribed in a circle with BAC equal to 70 and ADB is equal to 40. AD is 4, BC is 6. What is AC? So let's draw a little circle here, and let's try to make this look reasonable. Not entirely sure what it looks like, but I'll try to make it believable. Let's see here. And something like this, I guess. And then they want AC, so this is going to be AC. Let's label this now. A, B, C, and D. And the angles they give me are what? BAC is 70. So this is 70 degrees. ADB, oh, they've introduced another one in here, is 40. AD is 4 right here, and BC is 6. Okay. Well, the first thing is there's two angles that are probably equal, and those are BAC and BDC. And let me explain why. First of all, where is BAC? BAC is right here. BAC. And then the other one is BDC. So I got to draw on that line there. That one. And BDC is this one. The reason those two angles are the same is because they subtend from the same 2 points, B and C. You notice? And they land on the other side of the circle. And then if you do another similar type of thing where you take lines from B and C and hit the other side of the circle, they get to D. So therefore, that's why they're equal. All right, so now that we've established that, we know that because this quadrilateral is on a circle, it's cyclic. It's a cyclic quadrilateral. And cyclic quads have a very unique property that the opposite angles add up to 180. So this plus this is 180, and this plus this is 180. So based on that, we know that since this is 70 right here, BDC, since it's equal to BAC, and we know that ADB is 40, so ADB, this is 40, we know that ADC is 110. You just add those up, so angle ADC is 110. And then because it's cyclic, the other angle on the other side, this guy, which is ABC, angle ABC, will be 180 minus 110, and that is 70. So this angle is 70 degrees. Well, look at that triangle now, in particular this guy right here. Two angles are 70 degrees, so that means that is an isosceles triangle. Those two sides are the same. So if this is 6, then that means AC is also 6. And that's what they're asking for, AC. So number 13, the answer is B. A circle of radius 2 is centered at A. An equilateral triangle with side 4 has a vertex at A. What is the difference between the area of the region that lies inside the circle but outside the triangle and the area of the region that lies inside the triangle but outside the circle? All right, let's draw coordinate axes here, and let's see what we can illustrate. So I've got a circle that's got a radius of 2, right? So something like that, let's say. And then we've got an equilateral triangle that is such that it has a side length of 4. So I think this is a pretty decent diagram. Now let's talk about what they want. They want the difference between the area of the region that lies inside the circle but outside the triangle. So that is going to be this region right here in blue, right? Inside the circle but outside the triangle. Then they want you to subtract from that the area of the region that lies inside the triangle but outside the circle. Inside the triangle but outside the circle, I believe would be that region right there. So basically they want you to subtract, I'll just call it B minus A, I guess. It doesn't really matter what you call them. A minus B, B minus A, it's up to you. So this blue region I've called A, and this orange region I've called B. Okay, so let's individually figure out what is A and B, and then we'll subtract them. Well, A is really just a circle with that pi segment cut out of it. And that pi segment, since it's equilateral, this is 60 degrees, and that's very helpful. So it's essentially just pi r squared minus 60 over 360 pi r squared. That's it, really. So that is going to be pi r squared minus what? 1/6, right? Pi r squared. So this is just 5/6 pi r squared. And some of you probably would have just written this immediately. But I always like to explain things because not everybody, would know that immediately. So now the radius is 2, so we just plug in 2, and that would be 4 r squared. R squared would be 4. And then this is just, 20 over 6, which is 10 over 3. So 10 pi over 3. So there we go. This A is 10 pi over 3. Now I've got to figure out B. Okay, B is what? B is going to be the area of that triangle minus this pi segment. Okay, so that 1/2 base times height. The base is 4. The height, that I don't know yet. Okay, so I got to figure out that height. Okay, it shouldn't be a problem. The height is like there, right? Top to bottom. And this is a 30, 60, 90 triangle. This is 60, this is 30 degrees. This is obviously 90 degrees down here. So the ratio of the sides, as always, are 1, 2, and root 3. So if this is a height, then that means that h over 4, since this is 4, is the equivalent to the ratios, which are root 3 and 2. So that means h is equal to 2 root 3. All right. Okay, so now we can go back and calculate the area. 1/2 base times height, which is 2 root 3, and then minus that pi segment, which is 1/6 of pi r squared, and r is 2. Okay, so this gives me what? 4 root 3, I should say, and then 4 over 6, so 2 pi over 3. All right, so we're done. So now I just have to figure out A minus B. A minus B is going to be 10 pi over 3 minus 4 root 3 plus 2 pi over 3, right? Because I'm subtracting. So that is 12 pi over 3 minus 4 root 3. That is 4 pi minus 4 root 3. 4 pi minus 4 root 3. 4 pi minus 4 root 3 is this one. They just factored out a 4 for some reason. I don't know why. Number 14, therefore, is D. At Rachel's school, an A counts 4 points, a B 3 points, a C 2 points, and a D 1 point. Her GPA on 4 classes she is taking is computed as the total sum of points divided by 4. She is certain that she will get A's in both math and science, and at least a C in each of English and history. She thinks that she has a 1/6 chance of getting an A in English and a 1/4 chance of getting a B. In history, she has a 1/4 chance of getting an A and a 1/3 chance of getting a B independently of what she gets in English. What is the probability that Rachel, however you pronounce it, will get a GPA of at least 3.5? All right. Well, math and science, she is convinced that she will get an A. So she'll get 4 points for each of those. For English, she has according to her, a probability of 1/6 of getting an A and 1/4 of getting a B. And then she also could get a C. And I guess the C is, they don't tell us, but obviously it's the other, so the other percentage or portion of the percentage, which would be 1 minus 1/6 minus 1/4. And that's 7 over 12. And then history. History, she has, 1/4 chance of getting an A, 1/3 chance of getting a B, and then, of course, the C is going to be 1 minus 1/4 minus 1/3. They don't give us that. They make us calculate it. All right. So this is the full story here. Now we want a GPA of at least 3.5, so that means 3.5 times 4 courses is the total number of points, and that is 14. So total number of points is she has to get 14 points. Well, she's going to get 4 and 4 from math and science, so 14 minus those 8 means she's got to get at least 6 points from history and English combined. All right? Okay. So, what are the possible combinations she can get for English and history? English and history. She can get AA, AB, AC. She can get BA, BB, BC. She can get CA, CB, and CC. Okay, now let's talk about the points. This will be 4 and 4, and that's 8. This will be 4 and 3, that's 7. This will be 4 and 2, that is 6. Right? This is going to be 3 and 4, which is 7. This will be 3 and 3, which is 6. This is 3 and 2, which is 5. And this is 2 and 4, which is 6. This is 2 and 3, which is 5. And this is 2 and 2, which is 4. So she's got to get at least 6 points in English and history. So she's got to get this scenario, this, and this. The other ones are too low. So let's calculate the probabilities. The first one, an A and A is going to be 1/6 times 1/4. And then the next one, an A and a B will be 1/6 times 1/3. The next one, an A and a C, is 1/6 times 5/12. The next one, a B and an A, is 1/4 times 1/4. And the next one is a B and a B, 1/4 times 1/3. And the last one is a C and an A, which is 7/12 times 1/4. All right. So when you do this whole math, what do we get here? We have 1/24 plus 1/18 plus 5/72 plus 1/16 plus 1/12 plus 7/48. And when you add up all those fractions and reduce it to lowest terms, you get 11/24. 11/24, and therefore number 15, the answer is D. A regular hexagon with sides of length 6 has an isosceles triangle attached to each side. Each of these triangles has 2 sides of length 8. The isosceles triangles are folded to make a pyramid with the hexagon as the base of the pyramid. What is the volume of the pyramid? All right. Well, let's just draw a basic diagram. Now, the volume of this shape, when you flip up these triangles and make a pyramid, is 1/3 the area of the base times the height of that total pyramid. So I'll call that HP. All right, well, the height I will figure out right now in a second, but the base is right here. This is the base, that hexagon. All right, so shouldn't be too bad. When we flip this up, right, I will actually draw it first on here flat. When we flip it up, I obviously have to calculate a height. So I'm going to have to calculate some sort of height. And the base is going to be on the hexagon, and then the hypotenuse will be one of the sides. So let me explain here. So when we flip this up, we are going to obviously need a height that starts at the center of that hexagon and hits the top of the pyramid. And when you bring it up, we will need to calculate the length from there to there. And the length from there to there, from the center to the edge, is represented right here. And then when we fold it up, the hypotenuse of that triangle will be right here, which they have said is 8. And then the height will be going from this center all the way to the top. And that's what I've drawn here in that red line. That's going to be my height of the pyramid. So it takes a little bit of visualization, but that's how you would do that. But unfortunately, I don't know this guy right here. Well, the good news is that can be easily figured out by drawing a line straight across like that. And when you do, I hope you can see that this is the same as that, the length. And they told us that the length of the sides is 6. So if that's 6, this is 6. So this guy is 6. And there's a longer way of doing this where you actually use that and then, blah, 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 but it takes a lot longer. And as always on math contests, you try to do it as quick as possible. So this is the quicker way. All right, using Pythagoras, we can easily figure out HP now. It'll be plus 6 squared is equal to 8 squared. So 64 minus 36 is what? 28. So HP squared is 28. So HP is root 28. Okay, now all I have to do is figure out the base. Now some of you have memorized the formula for figuring out the area of a hexagon. And those of you who have not, it's not a problem. I'll do it in the longer way, which is where you just cut it into sections like that. And you can easily figure out the dimensions considering the fact that this is a 60, 30, 90 triangle, right? Because internal angles of a hexagon are 120. That means this is 120, this is 120, and so on. And since this is a right angle, this will be 30. Okay, so that's 6. And remember the ratios, as always, are 1, 2, and root 3 for these sides. And using those ratios, you can easily figure out the dimensions of those two sides. It's going to be 3 root 3 here and 3 for here. Okay, so the area of the base now, let's do it down here. Area of the base, it's going to be the triangles plus the rectangle. The rectangle is this guy right here. And since this is 6, it's going to be 6 times 6 root 3, right? Because we want the full from there to there. And then plus 2 of those triangles, so 2 times 1/2 base times height. The base is 6 root 3, and the height is 3. So this is 18 root 3 plus 18 root 3. Actually, 36 root 3. 6 times 6 is 36, not 18. And that is 18 root 3. Okay, so that is 54 root 3. Okay, well, so all we have to do at this point is just go back to my volume formula and substitute it in. So the area of the base is 54 root 3. And then the height I had previously figured out is root 28. So let's see here. That becomes 18 root 3. Root 28 is what? 4 times 7, so 2 root 7. And this combines to give you 36 root 21. 36 root 21. Answer for number 16 is C. An unfair coin lands on heads with a probability of 1/4. When tossed n times, the probability of exactly 2 heads is the same as the probability of exactly 3 heads. What is the value of n? All right, well, before I dive right into the question, let's talk a little bit about this question. Hopefully it will shed some light. Let's say n is equal to 5. And I asked you, how many different scenarios are there? Well, you can have 5 heads, and that's pretty straightforward. Every time you flip, it's a heads. You can have 4 heads, and that's obviously H, 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 and then 1 tailed. But this is written in several ways, not just in one way. As you can see, the tails can happen either the last one or the 4th one or the 2nd one and so on. So when you write it out like this, you will clearly see that there's 5 different ways of having 4 h's and 1 tails. Now 3 h's. Now I'm not going to write them all out. Unfortunately, you don't have to. There's an easier way of figuring out how many. Like I did there, I found 5. How many are there? Ways of making 3 h's. Use choose notation. From the 5 possible slots, 1, 2, 3, 4, 5, I want 3 of them to be h's. And that's it. And the other 2 will be tails. So 5 choose 3. And 5 choose 3 is, of course, 5 factorial over 5 minus 3 factorial over 3 factorial. And that is going to be equal to 10. So as you can see, you can quickly figure out that number without having to write all these, combinations. Now, what if I said, how about 2 h's? Okay, from 5, choose 2. And then the other 3 would be tails. Same thing, 5 factorial over 3 factorial over 2 factorial. And that, again, is 10. So as you can see, that is a very quick way of figuring it out. Now let's turn our attention to the question. We are not told what is the value of n. Okay, well, I think that's not too big of a problem. But first, let's go back and explain this a little bit more, because I want you to fully understand what I'm going to do here. I have 10 ways of making 3 heads and 10 ways of making 2 heads, right? But what is the probability in this particular question? Okay, well, for the first scenario, 3 heads, we have 10 ways, and for each way, we have 3 heads. So a head happens with the probability of a quarter, and a quarter, and there's 3 of them. That's why I wrote a quarter 3 times. Then we have 2 tails. 2 tails, each tail happens with the probability of 3 quarters, right? So that is the probability total of getting any scenario with 3 heads. And if you do this math, you get 90 over 1024. Yeah. Now let's do the 2-head scenario. 2-head scenario, again, we have 10 of them. The first head is 1 quarter probability. The second head is another quarter. But then I have 3 tails, so 3 quarters, 3 quarters, and 3 quarters. This probability is 270 over 1024. Okay, so that's how we did it. And as you can see, these are not equal. Since those are not equal, I eliminated 5 as an answer choice by going through it all. I wasn't trying to do it like that. I wasn't trying to eliminate 5. I just wanted to explain the question. But we know it's not 5. So now we will approach the question. We want 3 h's and we want 2 h's, and we want both of those probabilities to be equal. Well, how do we get 3 h's? From n, choose 3. And that is n factorial over n minus 3 factorial over 3 factorial. And when you simplify this, it becomes n times n minus 1 times n minus 2 all over 6. All right. How do we get 2 h's? Well, from n, choose 2. And that is n factorial over n minus 2 factorial times 2 factorial. And that is n times n minus 1 over 2. Okay, so now we're ready for this part of the question where you have to look at the probabilities. So we want 3 h's, that probability, to be equal to the probability of 2 h's. So what is the probability of 3 h's? Well, first we have to take the number, the big bag number here. So that is what? N times n minus 1 times n minus 2 over 6. That was represented by a 10 over there, but this time we don't know what n is. Then I have to take the probability of a head and multiply it by the number of heads. And it's 3. So it's 1 quarter times 3. Exactly what I did here, interestingly. And then I have to take 3 quarters and multiply it by how many tails? Well, here it was 2 tails, but here it's n minus 3 tails, right? Because we have n. We don't know what n is. Okay, so I hope that makes perfect sense. Now let's do the 2 h's. 2 h's, we have to take this number now, n times n minus 1 over 2, and then we have to do the same thing. A quarter, there's 2 of those, 2 h's, and then 3/4 is how many tails, and that is n minus 2. So this is the equation we have to solve. All right, so a bunch of stuff will cancel. Let's see how much can cancel here. The n's will cancel, the n minus 1 will cancel, and let's see what else. The 2 will cancel to give a 3. So let's put that there before we forget, and then the n minus 2. And then the 1/4 to the power of 3 and 1/4 to the power of 2 will cancel to just give a quarter on this side. And then these guys, this will cancel with that to give just a 3/4 on the other side. And that's it. So now it's basically just n minus 2 is equal to 9, and therefore n is equal to 11. So it's a very good question. Number 17, the answer is D. For every composite positive integer n, define r at n to be the sum of the factors in the prime factorization of n. For example, r50 is 12 because the prime factorization of 50 is 2 times 5 squared, and 2 plus 5 plus 5 is 12. What is the range of the function r? All right. What we can do is make a list and see what kind of numbers we get. So remember, composite numbers are basically numbers that are not prime. And 1 is also not a composite. So we're not going to include 1, and we're not going to include any of the prime numbers like 2, 3, 5, 7, 11, 13, 17, 19, and so on, right? Dot, dot, dot. So we're only going to use composite numbers. So we're going to use 4, 6, 8, 9, 10, and so on. So I'll just do a few. I think we'll be able to get an idea after a few. So I think, what's that, about 10, 9, 10? I think that's good enough. Okay, so the first thing we have to do with each number, each composite number, is break it up into its prime factors. So 4 is 2 times 2, and then we have to add them to get this r at n function. Okay, well this is 4. Let's do the same with 6. That's 2 times 3, so we have to now add those prime factors, and that's 6. 8 is 2 times 2 times 2. When you add them, you get 6. Sorry, this should have been a 5. 2 plus 3. Don't make that mistake. Okay, 9 is 3 times 3. When you add them, you get 6. 10 is 2 times 5. When you add them, 2 plus 5 is 7. 12 is 2 times 2 times 3. When you add those prime factors, you get 7. 14 is 2 times 7. Adding, you get 9. 15 is 3 times 5 when you break it up. And when you add those, you get 8. 16 is 2 times 2 times 2 times 2. And when you add those, you get 8. Okay, I think we have a pretty good list here. Let's look at the answer choices, see how many we can eliminate. So far, this is my list. It keeps going, but so far, that's what I have. That is what? Is it the set of positive integers? Well, it looks like it is going to be, right, 4, 5, 6, 7, 8, 9, perhaps, but we are not. We are missing. We don't have 1, we don't have 2, and we don't have 3. So it's not the full set of positive integers. The set of composite positive integers. Okay, perhaps. But here's the problem. We got a 5 in there. 5 is a prime. So all these numbers are not composite. So that one's out. The set of positive even integers. Well, again, 5 is not even. So that's out. The set of integers greater than 3. Yeah. So far, 4, 5, 6, 7, 8, 9. So that's right. The set of integers greater than 4. Greater than 4. Well, 4 is in there. So that disqualifies choice E. So by process of elimination, 18, the answer is D. In triangle ABC, angle C is 90, AB is 12. Squares ABXY and ACWZ are constructed outside of the triangle. Points X, Y, Z, and W lie on a circle. What is the perimeter of the triangle? We definitely need a diagram, so here we go. Here's exactly what they have said in the question, but in diagram format. Let's explain this. This is triangle ABC, obviously, and C is 90 degrees right there. And then AB is 12, from there to there is 12. Now, since it makes a square like that, all of those sides are going to be 12. And even if you draw a line that cuts through like that, it'll be 12 also. And then those squares ABXY, here's ABXY, and ACWZ is here, ACWZ. And the points X, Y, Z, and W are on that circle that I drew in green. So they want you to figure out the perimeter of that triangle. All right. Well, one important point, that this is the center of the circle, and the center of the circle lies on the perpendicular bisectors of X, Y, and WZ. So that's a really important part of that question. So what are those perpendicular bisectors? Well, they've been put in there like as dashed lines, right? There you go. And we have to label them, and that's what this is. This is 12, since it represents the same as the side of the square, and that side of the square was the same as AB, which is 12 right there. And then on the other square, we don't know, so we can call the side length 2B. And therefore, when you cut it in half like that, this becomes B and B. So this is B already labeled, and from here to here is B, like that. And similarly, this is already labeled as B, and from here to here is B. And this is labeled as 2B appropriately. Now, this side of that rectangle we label 2A. And therefore, since this is a bisector, it cuts this half, it cuts that side in halves. So if that full length is 12, this will be 6, and this will be 6, like that. And when you drop a line from that midpoint down, it will cut this in half, but it will also mean that that distance is half of this distance. So that's why that is labeled as A, since this is 2A. So I hope all that labeling makes sense. So now we can use Pythagorean relationships. The first one is right here. That gives you A squared plus B squared is 6 squared. The next Pythagorean relationship is involving this triangle right here. That is going to be 12 squared plus 6 squared is equal to OX, but OX is representing the radius of the circle. And then the last Pythagorean relationship I will use is this one right here, this triangle. That one, we get B squared plus A plus 2B all squared is equal to R squared. So this is the system of equations that we need to figure out, to use to figure out the values of A and B. Once we have the values of A and B, we can figure out the perimeter of that triangle. The perimeter of that triangle is going to be 2A plus 2B plus 12. So obviously we have to figure out what is the value of A and what is the value of B. All right, so now we've got a whole bunch of algebra, so here we go. So this gives me A squared plus B squared is 36. This gives me R squared is equal to 180. And this one, if you expand it, you get B squared plus A squared plus 4AB plus 4B squared is equal to R squared, which is 180. But B squared plus A squared is 36. So I can put that in there. And then I can put everything on one side. 4AB plus 4B squared is equal to 144, and then I can divide through by 4 to get AB plus 4B squared, or just B squared actually, is equal to 36. Yeah. Let's move this up here. Now I can isolate for A. A will be 36 minus B squared over B. Okay. Now I can substitute it back into my A squared plus B squared equals 36 formula. And that gives me 36 minus B squared over B all squared plus B squared plus equals 36. This becomes 36 squared minus 72B squared plus B to the power of 4 over B squared plus B squared is 36. Multiply through by B squared and you'll get 36 squared minus 72B plus B to the power of 4 plus B to the power of 4 plus 36B squared equals 36B squared. Put everything on one side, and when you do, you get 2B to the power of 4 minus 108B squared plus 1296 is equal to 0. Divide through by 2, and we get B to the power of 4 minus 54B squared plus 648 is equal to 0. So that means B squared using a quadratic will be equal to 54 plus or minus the square root of 54 squared minus 4 times 648 all over 2. And therefore B squared will be 54 plus or minus 324 root. And therefore B squared, if you do the math here, will be 54 plus or minus 18 divided by 2. And that gives me B squared is equal to either 18 or 36. So B is either 3 root 2 or 6. And looking back at the diagram, B obviously has to be less than 6, right? Because the hypotenuse is 6. So the only one that's valid is this one. If you substitute this value for B back into A, let's do that. A is 36 minus B squared, which is 18, divided by 2, divided by B rather, which is 3 root 2. So A is 18 over 3 root 2. So let's see here, top and bottom by root 2. That gives me 18 root 2 divided by 6. So that's 3 root 2. Oh, A and B are equal. Okay, interesting. All right, so now we have to figure out the perimeter after all this algebra. It was 12 plus 2A plus 2B. So that's 12 plus 2A, 6 root 2 plus 6 root 2. So that's 12 plus 12 root 2. And there we go, 12 plus 12 root 2. And that would mean number 19 is C. For every positive integer n, let mod of n to the 5 be the remainder obtained when n is divided by 5. Define a function f of 0, 1, 2, 3, dot, 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 times 0, 1, 2, 3, 4 goes to 0, 1, 2, 3, 4 recursively as follows. What is f 2015 2? All right, what we are going to do is make a table, and in that table we will try to see some sort of a pattern if possible. In this table, this is going to be my j values, and they have told me that j is anywhere from, it looks like 0 to 4 based on their recursive pattern. So j 0, 1, 2, 3, and 4. So this column is j. And then here I will put my values for I right here. And I believe, I goes on forever. There's no actual limit. So it starts with 0, obviously, and then it just goes up from there. So 0, 1, 2, 3, 4, 5, 6, and so on. All right. Without too much pain, let's go through this. Okay, so let's first start with the mods, and that's this guy right here. So that will allow us to figure out F00, F01, whenever basically I is 0. That's pretty much the definition. 02, 03, and 04. There's only 5 of those guys. Okay. Basically, you're going to figure this out. It's j plus 1. Divide that by 5. What is the remainder? Well, in the first one, this is my j. So if I add 1, it's 1. 1 divided by 5. The remainder is 1. So this is 1. And very similarly, you can do that. And I don't want to talk you through it because it's painful to listen to me talk you through every single one. I'll just walk you through the first one, and then the rest are exactly the same. So when we fill in this table, exactly like what I did over there, it's 1, 2, 3, 4, and 0. Okay? All right, let's move forward to the next one. The next one I'd like to do is this one, and that is when I is 1 and j is 0. So I have f at 1, 0. And to do that, obviously, I have to use this part of the recursive pattern right here. So that means, based on that, it will be f of 0, 1. And that is 2 from up here. So there we go. I put 2 in there. Okay, so now that that is done, let's keep going. Now I'd like to concentrate on these guys here. So that means I is 1 and j is anywhere between 4 and 1 inclusive. So I'm going to use this part of the recursive. So I'll just do the first one. So the first one is f at 1, 1. And using this, it becomes f at 0 and then f at 1 and 0, like that. And that becomes f at 0. F at 1, 0 is 2. So that becomes f at 0, 2. And f at 0, 2 is 3. So we put it. Next one is f at 1, 2. And that is f at 0. F at 1, 1. And that would be f at 0, 3. And that is equal to 4. The next one, 1, 3, f at 0, f at 1, 2, which is f at 0, 4, which is 0. And the next one is f at 0, f at 1, 3, which is f at 0, 0, which is 1. So go back and fill in the table. So I've got put 3, 4, 0, 1. So 3, 4, 0, and 1. All right, so I hope you're getting the hang of this. I'll just do a few more, and then I'll let you fill in the rest of the table, because it's really just using those recursive patterns. And those recursive patterns I've already done several times already. So I'll just do one more. I'll do this column right here. So the next one, of course, is right there, and that is when we have I is equal to 2 and j is 0. And that is using the pattern f at 1, 1, and that is, of course, 3. So this goes here, 3. And then now I've got to figure out the ones for I equals 2, these 4 guys, for j between 4 and 1. So that means f at 2, 1 is going to be f at 1, f at 2, 0, and that is f at 1, 3, and f at 1, 3 is 0. And very similarly, f at 2, 2. I'll just do a few more. F at 1, f at 2, 1. And that is f at 1, 0. And that is 2. F at 2, 3. That is f at 1, f at 2, 2. Which is f at 1, 2. And that is 4. And one more, 2, 4. Is f at 1, f at 2, 3, and that is f at 1, 4, which is equal to 1. So let's fill that in. So I got 0, 2, 4, 1, right? So 0, 2, 4, 1, and so on. So and so on, dot, dot, dot. So I hope what I've done illustrates how to fill out that table. It's a very time-consuming question. It's you only have 3 minutes on a math contest. I'm always amazed at how people can do this. If you fill in the rest, you get the following. It takes a long time, actually, to even see a pattern in this question. And you have to actually get to the point where you get to these I equals 5 and 6 to see that it just continues as ones. So anytime you get up to 5 or 6 and beyond, it's always going to be 1. And what we actually want is a scenario where I is 2015, right? So it keeps on going, dot, 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 and we want 2015. Well, 2015 for I, and j is always going to be between 0 and 4. That's also going to be 1, 1, 1, 1, 1. And in particular, we wanted 2015 for I and 2 for j. So it's this one right here. So very time consuming. 2015, 2. The answer is 1. So number 20, that would be B.